API servers that matches what you need to run on top of it. Okay, so workload domains, right, are made up of one or more clusters, right? And these can be expanded, they can be upgraded, they can be created or deleted through a single pane of glass, which is what we call the SDDC manager. So everything floats through the SDDC manager. So it makes, manageability a lot easier for you as well. Okay. And of course, if you have any other third-party solutions, things like your external storage or third-party software like your Palo Alto firewalls or any external API integrations, you can also include them inside as well. So this is exactly why we call this an application-ready infrastructure. Now, I'm going to talk a little bit more about the lifecycle capabilities that we have in VCF. Okay, so in a Cloud Foundation stack, right, we have this lifecycle management feature, and this is only unique to Cloud Foundation. So you don't find this in any other solutions that we have. So in a stack, you have multiple components, right? Say you have your EXXI, your vCenter, your vSAN, and your NSX, right? And these different great solutions, right, they actually have updates that happens over time, and not just over time, right? Over different periods of time. Okay, so typically how you've done things today is that you go online, whenever there's a new update, you'll go online, you will download the release notes, you will take a look into the release notes and understand what's inside the update, what consists of the update, right? And then you'll figure out which parts are going to be interoperable with what, and what is the update process like. Basically, what comes first, second, third, etc. Right? So these are things, right, that you don't have to be worried over anymore, because our engineering team has basically done the work for you, right? This is handled all for you by our lifecycle feature in the SDDC manager. So our engineering team, what they did is that they basically gathered all the different updates, they put them together and present it to you as a single update bundle. So it's easier for you to manage it right now. You don't have to go through the trouble of doing all these manual checks. And of course, for customers, right, who have really large environment, right, but very small maintenance window time, they might find it useful that, to apply an update to specific classes in that workload domain. You can also do that as well. So you don't have to apply an update across, the whole entire workload domain. You can actually pick out and choose very specific classes that you want to have the update for. Okay, so we offer you that kind of flexibility. And if you take a look at it from a very general overview of how all this works, is that whenever we release an update bundle, your SDDC manager is going to receive a notification, right? And then you can click on the notification. You can proceed to review the updates, like how you have done things today. And then once you okayed it, you can actually schedule for an update at the very present moment, or you can actually schedule for a later time when you have scheduled for downtime, for example. So all these things are done through the SDDC manager, and it makes it a lot easier for you as the IT team. So now I'm going to do a walkthrough of how this lifecycle process works, right? And how it looks like in your SDDC manager UI. So if you take a look right now on the screen, right, you will see a screenshot, and right in the middle, you will see a tab called Updates and Patches that's underlined in blue, right? And next to the text, you will see a value of 1, this icon. So this icon, right, actually represents the available patches that you have and is applicable to your workload domain. So what you'll do is that you can actually click on it. You can actually review the updates, understand what's inside the update bundle, what are some of the changes that, will be happening to your environment. And then once you're okay with it and you want to go ahead with updating it, what you can do is that before you click and trigger the update button, you can actually run a pre-check. Okay, so what this pre-check does is that it basically runs a series of tests. And this test, right, is going to make sure that your update process or your update is going to be completed successfully. So it just verifies that for you. Okay, so assuming that you've run the pre-checks and it passed the pre-checks, you're going to get notified in the yellow bar saying that this management domain has passed the pre-checks. So this is your cue now to actually schedule for the update. Okay, and like I said earlier on, you can either schedule for an update at the very present moment, or you can actually put it off to a later time. So we have a really nice calendar widget for you to actually pick and choose a suitable date and time for you to have the update. Okay, so assuming in this case, I will go ahead and update it now. So for any other admins who log into the UI, they will be able to see that there is an ongoing or scheduled update that's happening right now. So you can basically see that in my screen right now that's highlighted in the red box. Okay, so once that's done, you will then get a final notification in the green bar saying that the update is successful and it's completed. Okay, so it's really straightforward as well. So like I mentioned earlier on, for customers who have really, really large environments, they have many hosts, many clusters, sometimes it doesn't make sense for you to apply an update to the entire workload domain. So you might find it useful, to pick out specific clusters that you want to get the update first. So this is how it will look like in the UI, right? You basically get, a list of your classes in that domain. You can check the boxes to pick out the classes that you want to have the update for. And then, very similar to the previous demo that I showed you, you can also pick and choose a suitable date and time for the update to happen. Okay, so one thing to note is that for the classes, right, the classes will get updated one at a time. So even if you check 3 different classes for it to have the update, it will happen one at a time. Okay, so it's really simple as well. Now, how does our SDDC manager, gets all the update, right? So basically, for customers with internet access, when they have internet connectivity, right, what happens is that the SDDC manager is going to go ahead and authenticate and go to the VMware depot, and then if there's an available or an applicable update bundle, you can actually download the bundle to your SDDC manager, and then you can install the bundle through our single-click upgrades. So it is really straightforward. Okay. So we also recognize the fact that, actually not all customers would have internet connectivity, right? Not all customers would have internet access, right? Because of, the way that the business is run. So in this case, all you need to have is a separate PC or a separate laptop with that internet access. And then from there, from a very high level, what you're going to do is that you're going to use that PC. You're going to connect to that VMware depot. You're going to find all the applicable bundles, download it to that PC, and then you're going to transfer it over to your SDDC manager. Okay, so then you can proceed, to update it and install it as well. So this is from a very high level overview. So of course, there's a lot of details as to how you do this exactly. So for these details, you can always refer to our official documentation. Okay, but in a gist, right, we basically cater for customers for both ways, right, both methods, whether is it an online lifecycle management or an offline lifecycle management. Okay, now in vSphere 7.0, we actually released a new lifecycle manager feature, right, and we call this the VLCM, vSphere Lifecycle Manager, right? So this VLCM feature, right, or tool, it is basically the next generation replacement to VUM, or vSphere Update Manager, right? So we should be quite familiar with vSphere Update Manager for customers who are using that to update and upgrade your EXXI, okay? So the difference is that VLCM, right, it's actually built based on what we call a desired state model, okay? And what this means is that very simply, you're able to define what is the baseline that you want to have for your host, your EXXI host, right? And at any one time that this actually deviates, your host configurations deviates away from what you defined at the start, it will basically remediate it by bringing it back to the original configs. Okay, so to put this in layman terms, imagine you have a hot pot, right? And then in the hot pot, you first pick out the base soup, right? Which is, in this case, is the base image. And if necessary, or if you want to, you can also add in the extra stuff, your extra ingredients, right? So things like your vendor add-ons, your drivers, your firmwares, your I/O controller firmwares, things like that, right? And you can add it into the soup. And then the entire hot pot broth, right? The entire hot pot will be considered as your desired baseline. So at any one time that this moves away from that, right, you'll know that, hey, I want it to move back to my original, baseline. So this is how and why we call it a desired state model. Okay, so now, this is actually really great because VLCM, right, was actually built with vendors in mind. So vendors, right, can now actually specify very specific lifecycle updates through this framework using plugins. And these plugins are really easy to install. Okay, so VLCM basically takes care of the updates on your hypervisor level, but it also takes care of the full stack drivers and firmware. So all in all is that you just need to remember that not only do we allow you to update the software stack, but we also allow you to update the hardware stack. Right? So it's really quite a very seamless end-to-end process. So now let's take a look at the demo that I'm going to show you right now that basically describes and walks through this feature. Right?
In this demo video, we're going to take a look at the new Lifecycle Management feature found in vSphere Lifecycle Manager. Supporting server vendors will provide a Hardware Support Manager, or HSM, that once installed inside vCenter can be used to manage vSphere Lifecycle Manager. I'm using Dell R640s in my lab, so my HSM is Dell Open Manage Integration. But let's take a look at Lifecycle Manager first. A desired image in VLCM consists of a base ESXi image that can either be manually uploaded or pulled from a vSphere depot, and vendor add-ons that are packages or vendor-specified components like firmware and drivers. The first thing I'll do is create a host credential profile. This is where I give my username and passwords for my iDRAC as well as my ESXi hosts. I'll provide the servers in my cluster, and then I'll test my credentials. Next, you'll need to create a cluster profile that associates your firmware repository. I've already created one called Dell vSAN, so let's take a look. When choosing a firmware repository profile, I could just choose the Dell default catalog, but I want to make sure that my vSAN cluster has all drivers and firmware that are supported on the vSAN HCL, so therefore I've created my own DRM vSAN profile. Next, I'll select the servers in my cluster that I want to manage. I'll also choose a schedule for drift detection, and then click Finish. Now that I've determined my desired ESXi version and my vendor add-ons, it's time to put all of this together inside of my image. From the Select Firmware and Drivers add-on, I'm going to choose that Dell vSAN profile that I created earlier. Once I hit Save, this is going to validate both ESXi as well as the firmware add-ons that are inside of that profile against all of the servers that are associated with my profile. Upon compliance check, I can see that several of my servers are not in compliance. My ESXi version is fine, but I've got some outdated firmware, so I need to go ahead and remediate these servers. I can choose to remediate one server at a time, or remediate all. I'm going to go ahead and remediate all. At this point, VLCM will do one more compliance check to make sure that everything is the same, and then it will start one server at a time by putting the server in maintenance mode, moving the workload off non-disruptively, and then just like vSphere Update Manager VUM, perform a rolling upgrade of the servers. Information about the upgrade can be found here in the Updates tab, but for detailed logs, you can go to your Hardware Support Manager's Log tab. These are firmware upgrades, so each server will actually reboot and install the firmware, reboot again, and then do another compliance check. Logging into my iDRAC, I can see that the firmware upgrade is in progress. Once complete, the server restarts and runs a compliance check. Once it realizes that the servers are in compliance, it'll move on to the next server. If you're a VxRail customer, then you've already grown accustomed to these lifecycle management capabilities inside VxRail Manager. But for vSAN Ready Node customers, this is an exciting step in the direction of delivering simple, reliable, and consistent lifecycle operations for vSphere and HCI clusters. VMware Storage, real, today.
Right, so that actually concludes
just confirming that
the video that we have. So right now I'm going to introduce Chow.
See that event there?
So let me just get, So basically Chow is now going to discuss a little bit more about how VCF is going to be a great platform if you are deploying any modern applications. So Chow.
Hey everyone, thanks for dropping by this afternoon. So as you can see, what Valerie just showed you guys earlier was the key value proposition of VCF in general. So today I'm going to show you another 2 more additional use cases that a lot of customers actually use VCF for. And one of them is, let me just go to my next slide, is deploy modern apps. So my definition of modern apps, or rather the VMware's definition of modern apps, is Kubernetes and containers and whatnot. So for a lot of us, this is quite a new area, new challenging area for traditional VMware admins, and for developers alike, still kind of iffy how they can best consume containers on a VMware platform. So today I'm going to kind of show you briefly how VCF helps us solve this issue. But first, let's look at the roles and responsibility in a typical VMware environment working together with developers. So as you can see in this diagram, you will have the bottom section where VCF forms the basis of it. Like Valerie just went through, you have ESXi, you have NSX, you have vSAN, and all the usual components that form VCF, right? And then on top of that, you have the developers. In general, developers are not too concerned about infrastructure. They just want to consume. And the VMware admins, on the flip side, just really interested in making sure everything runs and not forgetting the traditional workload, which is the VMs, right? So they need to understand that, hey, I have a whole bunch of VMs and I have these new workloads as containers that I need to manage singularly. So how do I do that? So I'm quite sure you saw Valerie's slide as well in the recap that we group workloads by what we call workload domains. And in this essence of it, you can see here you have 2 boxes which you kind of say the VCF workload domain, and inside it, yes, vSphere. And for those who are very familiar with all that's come out from VMware in the recent times, Tanzu is like the next big thing since vMotion. Everybody knows what Tanzu is, right? I hope, in this call. So today we're going to talk a little bit about how VCF helps get you started on that journey. So coming back to the left-hand side of the slide, you can see the developer, right? The developer is interested, like I said, to develop, build cloud-native apps or CNA. They want to be able to do self-service. They don't want to be calling the administrator every now and then and say, hey, how do I do this? Can you provision me storage, whatnot, right? So they just want it to run a couple of lines and deploy via code, right? And on the flip side, like I said, the SDDC admin needs to sort out, hey, give me the resource, how much resource you need to give it. You need to manage virtual machines as well as cloud-native apps, as well as take care of the life cycle. You guys already kind of saw how Valerie took care of the life cycle with regards to all the components at the underlying section, right? But it's a little bit different with Tanzu. So with VCF, what Valerie didn't quite mention is also VCF takes care of Tanzu Kubernetes Grid's lifecycle as part of the deployment. Okay? So going to the next slide. Right. So the biggest challenge with a lot of virtual infrastructure admin or admin in general with regards to Kubernetes, I know I have this issue, is that understanding Kubernetes as a platform, right? We all find it quite clunky, difficult to deploy, or we're kind of still learning, right? There's a lot of command lines and whatnot. But what if I provide you an interface to right-click provision Kubernetes environment and all the ground up? We are talking about network, we're talking about storage, and the pod in itself, right? Create the workload domain, deploy NSX, which is the network, edge clusters, and the shebang, right? Wouldn't that be great? And effectively, VCF does all that. So today I'm going to show you a few things. I'm going to show you the steps involved in creating a Kubernetes environment in VCF to kind of let you have an appreciation how easy it is to do, and then also a short video of the entire process. Okay, so let's get straight into it. The first few sections here, I'm going to go through the step-by-step, right? Who does what in the entire environment. So as you can see here, there's 3 boxes. So the dark blue, the light blue, and the green. So let's take it as the green is where I hand off the deployment teams, right? Or the development teams, rather. So they run off kubectl, right? They run all kinds of commands, the usual stuff. It's nothing new on their side, but the powerful thing here is that they not only can deploy pods and containers, they can also use code to deploy VMs. So that's quite a nice nifty thing that they never used to have. Okay, but let's focus a little bit on the 2 blue boxes. SDDC manager perspective, the first thing we're going to create is to create a workload domain, the basics of it all. So I want to create like a virtual infrastructure domain, which is like, hey, you know what, there's 3 or 4 servers. I'm going to build, make it a workload domain for Kubernetes. And then I'm going to deploy an NSX edge cluster. This is where I deploy a NSX instance dedicated to this bunch of workloads. So we get the network running there. And then next is where kind of goes in between SDDC Manager and vSphere Web Client. That's where we enable and turn on the Tanzu Kubernetes Grid, or TKG. And from there on, the workload management will then deploy the content library, the namespace, and also Harbor for registry and images deployment. Okay. We'll talk a little bit to the dev team's perspective. Once we hand it off to the dev side, they will download the command line tools to interact. Okay, they can create their guest class, deploy containers, and consume the services. So that's pretty much straightforward. So I won't go too much into that discussion. Okay. So moving along, as an administrator for VMware, first and foremost, like I said, we need to create a workload domain. And in this case, we need a minimum of 3 hosts. If you have 4, that's best, right? Otherwise, 3 it works fine. So that diagram or that screenshot there is very common to you guys. You guys who have CCF in action would know that. It's nothing special. It is the same way we create a normal workload domain for, let's say, VDI or ESXi. Okay. So once you're done doing that, you deploy the edge cluster. So this is where we allow NSX to be integrated into the entire solution. In the past, this is a little bit clunky because you need to do a little bit of manual work. But with VCF4, as you can see from the screenshot, when you pull down, they have a section just for saying, hey, add edge cluster. And then by then, it's all just next. Put in the right details, and it will configure a tier 0, tier 1 logical router. And they make it known that, hey, you know what, this is for workload management, which is essentially the TKG or Tanzu Kubernetes Grid workloads. Okay, so next, it's where we get interested. It's different now, right? We enable vSphere for Kubernetes. When you initiate this particular part, what we then do is we do the prerequisite checks. Like, for example, hey, do you create the workload domain already? Do you deploy the edge cluster? If you've done all that, we now hand it off to the vSphere web client, and we install the K8 VIPs on the host and deploy the supervisor pods and instantiate the pod services. So in my next demo, do stay tuned because it is actually a video. It will be the entire motion of how we deploy this and what is required, etc., etc. Yeah, I'll just bring up the rest of the screenshot and going to the demo.
Welcome to this
wonder if the demo is playing for you guys. Okay, here you go. Sorry about that.
On VMware Cloud Foundation. So let's start in SDDC Manager. Here we have now extended SDDC Manager to add capabilities.
We are in the SDDC Manager, part of VCF 4.0, and just confirming that we have already deployed an NSXT Edge cluster. See that event there. And so now we're going to go and have a look at our workload domain. We can see the NSX components all available there. And of course, the whole objective here is to deploy a vSphere with Kubernetes. At the moment, there is no deployment in the workload management section, so we're going to go ahead and do that. So we're here in the prerequisites. There's obviously a license required to do vSphere with Kubernetes, and the other things are all to do with NSXT, NSXT.
So hopefully you guys have seen that demo a little bit. So as you can see, there is really no command lines at all. It's really next. It's all very visit driven. So you don't actually have too much to need to know about how all those pieces tie together as a virtual infrastructure admin. And once that's complete, the next thing, the logical thing that you want to do is we want to create a new concept within vSphere called the namespace. So what exactly is a namespace? What we saw just now was a creation of the entire supervisor cluster, the cluster that manages the entire Kubernetes pod. However, if you just pass it on to, let's say, the developer, what's going to happen here is that he's going to have free reign of all those 3 or 4 servers completely, right? There is no more resource management and whatnot. They pretty much can consume everything there is to consume. So think of namespace as a new version of resource groups or something along those lines. So we'll create a namespace, and then we'll say, hey, you know what? In this particular namespace, you can X amount of CPU, X amount of resources like memory, storage, etc., etc. And then you provide the permissions. Like for example, I'll just bring up the screenshot. You put the limits and you provide the permissions, and then you hand it over to the administrator for the DevOps side of things. And then they can consume to their heart's content, create new containers, use VMs, etc., etc. Okay, you can create as many container namespaces as you want, and then you just assign it accordingly. So as part of the deployment, we also allow you to deploy Harbor Registry. So think of this as a place where your DevOps guys or developers can actually put the certified images or signed images or signed repository internally. So it saves you from, it's a bit of a security thing more than anything else, but if this is what you need, you can deploy a Harbor Registry. So that's part and built into VCF4. Okay. So hopefully I've given you a high-level viewpoint of how VCF can help speed up or ramp up your go-to-market and time to market with regards to setting up a vSphere / Kubernetes environment. All this by having a very, very shallow learning curve. So effectively what you're going to get as a vSphere administrator is, a two-in-one platform, right? You can still manage your VMs of vCenter and whatever you can do through vCenter and SDDC Manager, as well as the next generation workload in containers. And all this, like I mentioned, you don't actually need to know a whole lot about Kubernetes. You run Kubernetes leveraging existing knowledge base of your particular IT operations and your day-to-day from a DR perspective to your day 2 runbooks. Okay. And the last point here is Cloud Foundation provides a standardized, repeatable method. So there's no such thing as a snowflake, right? You don't deploy one environment and then the next environment looks a little bit different. So effectively, you want the infrastructure to be very, very consistent. So every time you right-click and provision, it's very, very consistent. All the hardening, all the way we construct a pod, way we construct a workload, it's all very similar. So from a standardization itself, you get all that as well. Okay. So, word from our sponsors and the messages here. Please complete the survey form here. I know we have gotten a lot of good results and surveys previously from the guys. Before I go on to my next section, please complete this form and get yourself a chance to win the Ninja T-shirts. I'll give you guys 30 seconds to do that. All right, moving into the next section. So once that's sorted, the next big use case that we see a lot of customers asking us, and obviously with the pandemic and everything else, is business resilient infrastructure. There's no point having infrastructure that works very well but is not resilient, right? And then you have limited access to the data center these days. There's a lot of red tape to go through. So today I'm going to kind of walk you through some of the capabilities that we have in VCF4 that allows you to maybe make the environment more resilient or to have a better overview and management capability across your many, many VCF clusters if you have. Okay, first, let's look at the potential deployment scenarios in VCF. Obviously, you have the number one, which is a single site deployment, which is fairly straightforward. You deploy on site. And then you have the 2 and 3. So 2 is what we call the VCF stretch cluster deployment. So this is leveraging the capabilities within NSX to do stretch networks and as well as vSAN to do stretch replication of storage. Okay, and I'll go through a little bit of that today. And the third one is VCF multi-instance management. This is for customers who potentially have multiple clusters of it. And instead of, logging into one site and then, log out, log into the next site, we want to provide the end user a bird's eye view of the environment. So you don't actually necessarily need to kind of just, go into individual bits and pieces to manage stuff. Okay, so let's get into it. All right, so with regards to stretch cluster, it's fairly straightforward with stretch cluster. Effectively, you will need 3 sites. First, obviously the primary site, and the second one is what we call the availability zone 2 or the DR site. And the third site is really what we call a witness site. The witness site can just be a small computer room or a small server room in a branch office. There's no data going there. So what the third site is really used for as its arbitrator. So in the event there is like link failures, that site will be used as a voting mechanism, and that's all it's doing. The link between the third site and the 2 primary sites are generally very low. You can have fairly high latency. It can be even in another country if you wanted to. So, but the key here is between site A and site B, they need to have fairly robust infrastructures, so both sites can be active at the same time. So first and foremost, in VCF, in order to deploy a stretch cluster, you need to have similar amount of servers on both ends of town. So if you look at it here, at the right at the bottom, you have 4 servers, and on the AZ2, you have 4 servers, and that's the management domain. If you have 4 on each side, you need to have exactly the same on the other. So in this instance here, you will have 3 clusters on the side A that will be doing stretch, and likewise, you need to have replicator on the other side, but you will see that there is one particular cluster on site A that is not needed to be replicated. That one can be of any size, right, as you can see. And what I wanted to highlight here is you don't actually need to stretch everything. You can have workloads on each of those sites that are running independently and, you know, not needing the replication requirement, so to speak. So first things first, in order to deploy a stretch cluster in VCF, you first need to stretch the management domain. That is a prerequisite. Once that's done, you can pretty much do the rest as well subsequently, or not do it, like, you know, that third workload domain. So I'll just build out the slide, and in this diagram, you'll see that all 3 sites are stretched. Like I mentioned, you can actually have independent workloads on both sides that are not stretched and just operate within their own. So in this case, you will see in side B, you have a vSphere Kubernetes enabled workload and that is running independent, and on one side, you know, something that's independent. Okay? So fairly straightforward. So effectively, it is very, very easy addition to your existing vSphere VCF environment. So there's no need to really understand, you know, the complexity of, let's say, hey, you know what, if I want to go stretch my storage on network, how do I do next, you know, with a legacy 3-tier environment? For us, it's really all policy driven. So this is very, very much easy to be added to an existing VCF environment, so to speak. So moving along, we are getting more and more pickup rates on VCF specifically. So we have customers who maybe in Singapore itself, you know, have a few data centers, and then they may have one in Indonesia, one in Malaysia, Philippines, and whatnot. So they are saying that, hey, you know, Charles, I need an easy way to manage this stuff. I don't actually want to be like right-click, you know, go into one data center like I mentioned earlier and then log out and come back in. Is there an easy way to have a consolidated pane of glass, so to speak? So we then enable this new capability in VCF called the multi-instance management. So effectively, you can actually, you know, log in multiple units of VCF, and then they will, you know, manage each other, and then you can kind of peek into as a bird's eye view, and you can also double click into each and every one of those data centers to work on. Okay, so the next few minutes or 2-3 minutes, I will go through this demo video, and you guys will see how this works in reality, and have a better appreciation of it.
Hello, and welcome to this quick introduction about multi-instance management on VMware Cloud Foundation. So let's start in SDDC Manager. Here we have now extended SDDC Manager to add capabilities for multi-instance management. There's no additional component that needs to be installed other than upgrading to the latest version of VMware Cloud Foundation. Once there, you can go to the multi-instance management view. Clicking on that asks you to either create or join an existing federation. In this case, we're going to create a new federation. And here we can see the federation has been created, and we have a single member as part of that federation here in New York, and you can see the capacity from that single site. Next, we want to add more sites to the federation so that we can start to do multiple instance management. So you invite a member, you choose whether you want to enable high availability. For high availability, you need to designate 3 sites as being controller nodes. So now we can simply click the pairing link, which will take us to the remote site from which we can complete the pairing process. And here we are at the joining process at the Sydney site. We need to provide the site name and location, and the joining process takes a few minutes. So the join process is now complete. You can see the new site at Sydney in addition to the existing site in New York, and the aggregated capacity across both sites is visible at the bottom. We will now repeat this process and invite a few more instances to join the federation. So now we've got a total of 5 data centers in our federation. We've got 4 geographical locations, and we've got 2 data centers in Sydney. For each site, you can click and get a quick summary of the capacity, whether it's got any software updates pending, and a high-level overview of what the system is being used for. You can also view a more detailed view by switching to the table view, and here you can see all of the data centers and their aggregated capacity. And across all the data centers, you can see any software updates that are available at each site, and an aggregated capacity at the bottom. In this instance, we can see that the Delhi site seems to have a storage issue, and so we can drill down and we can now see that it's got 2 workload domains. The management domain looks to be okay, but the CNN Delhi VI domain 1 appears to be running low on vSAN storage. So if I want to go and now manage that further and investigate further, I can click the link and it will take me to that site from where I can perform onward remediation. And here you can see it's brought us to the workload domain page for that remote site. I can perform further investigative and remediation operations. And also from that site, I can view the entire rest of the federation, just like we could from New York. Well, I hope that was interesting. Thanks for watching.
So hopefully today we have given you a little bit of a sneak peek of 3 of the key major use cases with regards to VCF and what it can almost immediately bring value to your organization.